This is Jack Jackson. Let's take a look at a few more derivative interpretation examples where we're putting this the concepts of a derivative in a real-world context. So we're going to pick up with this problem here, number 56 you see here on the screen. The population of China in billions can be approximated by the function p of t equals 1.15 times 1.014 to the power t minus 1993, where t is the year. So if the year is 2017, you put 2017 in place of t. What was China's population at the beginning of 2014? Okay, well, you just plug in 2014 and work it out. Okay, so it's just p of 2014. And we work this out. We'll round off to 3 significant digits because of this coefficient here. And then here it is in the calculator. 1.15 times 1.014 to the power of parentheses 2014 minus 1993. Close parentheses, and here we get this. Actually, it's about 154, rounds off, billion people. What function describes how fast China's population was growing? Well, that would be the derivative. The derivative of a function tells you how fast that function is changing. So let me just do the derivative here. The derivative, this constant is going to come out front, constant multiple rule, and then we take the derivative of this part here that's left. That's like u to the, it's like 1.014 to the u. Okay, so b to the u. Well, b to the u, the derivative is b to the u, same thing, times the derivative of the u being the power. The derivative of that power is just 1. So put all that together, we get this. I don't know if I said this already, but when you have b to the u, it's b to the u is the derivative times the natural logarithm of b. So don't forget that part right there as well. So there's the function for the derivative. How fast was it growing at the beginning of 2014? Okay, beginning of 2014, the year is 2014. And we're assuming that 2014 is the beginning of 2014, not just some time in between there. That's the interpretation I'm using for the value of t. So you just take this formula and plug in 2014 and work that out. I think that's what I've got here in the calculator right here. 1.15 times natural log of 1.014 times 1.014 to the power of parentheses 2014 minus 1993. Do not forget parentheses around that power. It's going to be important. And that turns out to be approximately 0.02141 billion people per year. If we want to scale that back to million people per year, we divide by 1,000. That would be 21.41 million people per year. Again, this is rounded off. This 1.15, we probably should round that off to about 21.4 million people per year, because we probably don't have more than 3 significant digits of accuracy. What is the relative rate of growth, percentage growth in China's population? Remember that an exponential function, y equals a b to the t, or y equals a 1 plus r to the t, is growing by a relative rate or percentage rate of r. So that base is 1 plus the rate. So if we subtract 1 from that base, we'll get the relative rate. So 1.014 to minus 1 is 0.014. That's the relative rate. In a percentage form, that's 1.4%, and that's per year. Recall in general that a linear function has a constant rate of change, but an exponential function has a constant relative rate or constant percentage rate of change. Let's try another one. Completely different situation here. The f of x be the elevation in feet of the Arkansas River x miles from its source. What are the units of f prime of x, and what is its sign? See if you can figure this one out. You can even press pause if you want to think about it a minute. Okay, let's think about this. Let's think about the units first. Well, the units of a derivative are the units of the output of f of the function divided by the units of the input. So it's F units over X units. F is measured in feet, feet above sea level, right? And then X is measured in miles from the source. So it'll be feet of elevation per mile from the source, so feet per mile. Now what about the sign? Well, all rivers flow the same direction, downhill, right? It's because of gravity. So we know that the river is going to be going down as you go down the river. Okay? So basically the river is going to be decreasing. Now there's possibility there's a short period of time it might actually have enough power behind it that it goes uphill, or there may be flooding or something, which forces it a little bit higher. But in general, it's basically going down as you get further away from the source. So it's going. That means the function f is decreasing. Therefore, the derivative is negative. We'll pick up some more in the next video.